Obviously, there is huge interest in knowing what is actually happening to these cyclones under global warming. The GFDL group, I think led by Tom Knudsen, puts out a regular report on global warming and hurricanes based on their own studies and studies of other people. Obviously, they do focus more on hurricanes, but they always include something on global cyclones as well. This one is the latest one that you can find on their website. I will just go through the main bullet points they make, and then we'll come back and look at some figures. There are certain things that are already well established. For example, IPCC AR5 and AR6, which is about to come out, confirm with detection and attribution. I think most of you know what that is. There is a change in the signal that can be detected, and then there are various techniques used to attribute that change to see whether anthropogenic forcing is needed to explain that change. So sea level rise, which very likely has a substantial human contribution to the global mean observed rise, according to IPCC AR5, should be causing higher coastal inundation levels for tropical cyclones that do occur, all else assumed equal. Should be. So that attribution of actual increased coastal inundation hasn't been done yet. Tropical cyclone rainfall rates will likely increase in the future due to anthropogenic warming and accompanying increase in atmospheric moisture content. So as global warming is happening, and it is clearly attributable to human contribution to greenhouse gases, increase in greenhouse gases and the related energy increase. Rainfall is increasing in general, extremes as well, but then there is additional increase in cyclone driven rainfall, so that will likely increase. Modeling studies on average project an increase on the order of 10 to 15% for rainfall rates averaged within 100 km of the storm for a 2 degrees Celsius warming scenario. Okay, so there is general increase in rainfall, and then there is increase in rainfall associated with cyclones within 100 kilometers, and that's shown to be happening, or will that is projected to happen with 2 degrees C warming. Tropical cyclone intensities globally will likely increase on average by 1 to 10%, so large uncertainty there, according to model projections for a 2 degrees Celsius global warming. This change would imply an even larger percentage increase in the destructive potential per storm, assuming no reduction in storm size. So that's the maximum wind speed to the cubed kind of measure when you're talking about destructive potential. The storm size responses to anthropogenic warming are uncertain. Remember, we can talk about the intensity in terms of the maximum wind speeds and size, the extent of the cyclone's influence and its propagation speed, its direction. So everything can change, or the latitudes where hurricane cyclones can form, everything can change. Right? The global proportion of tropical cyclones that reach very intense category 4 and 5 levels will likely increase due to anthropogenic warming over the 21st century, likely, which is 66% probability, confidence level. There is less confidence in future projections of the global number of category 4 and 5 storms, since most modeling studies project a decrease or little change in the global frequency of all tropical cyclones combined. So it is not clear right now whether the hurricanes are going their own way, or if the other regions of the cyclones in the northern hemisphere, like the western Pacific, eastern Pacific, Indian Ocean, and the southern hemisphere, Indian and Pacific Oceans, also will follow the hurricanes, because the impact of warming on the North Atlantic is quite different in terms of the Atlantic multi-decadal oscillation. There are impacts of volcanoes to be considered, impact of aerosols to be considered, and whether aerosols and the Atlantic multi-decadal overturning Atlantic meridional overturning circulation is affecting the North Atlantic temperatures versus the tropical North Atlantic warming, and whether the cyclones respond directly to the tropical North Atlantic warming where the cyclogenesis for hurricanes happens, or whether that's related to the tropical North Atlantic warming relative to the Pacific. Very different outcomes can happen, right? So this science still remains quite debated. In terms of detection and attribution, much less is known about hurricane tropical cyclone activity changes compared to global temperature. Recent findings include in the Northwest Pacific Basin there is emerging evidence for a detectable poleward shift in the latitude of maximum intensity of tropical cyclones, with a tentative link to anthropogenic warming. Okay, so the tropics themselves could be expanding. There is evidence for that, but again, there are debates there. A new study finds an increase in the fraction of tropical cyclones reaching at least Category 3 intensity both globally and in the Atlantic Basin over the past 4 decades. These observed changes have not been compared with model responses to historical anthropogenic forcing or to modeled natural variability. They have not been confidently attributed to anthropogenic forcing. So intensity, fraction of cyclones reaching higher intensity can be detected, but is that really because of anthropogenic forcing or internal variability, which could include modes of variability like El Nino and Atlantic multidecadal oscillation and the Atlantic meridional overturning circulation, and their impact on the SSTs of the regions where cyclogenesis happens and cyclone evolution happens, right? So you can imagine the difficulties of doing these things. A study of rapid intensification of hurricanes finds that observed increase in an Atlantic rapid intensification metric for 1982 to 2009 is highly unusual compared to one climate model simulation of internal multi-decadal climate variability. So the signal over this 1982 to 2009 rapid intensification seems inconsistent with what has happened before and is consistent in sign with that model's expected long-term response to anthropogenic forcing. One model study, but obviously will be done with others, I'm sure. Plus, in the Indian Ocean, there is evidence that more rapid intensifications are happening since at least 2016. There is increasing evidence from modeling studies at GFDL NOAA and the UK Met Office Hadley Centre that the increase in tropical storm frequency in the Atlantic Basin since the 1970s has been at least partly driven by decreases in aerosol from human activity and volcanic forcing. Natural variability may also have contributed to recent changes. So there is volcanic and human aerosol impacts. The recent GFDL and UKMO studies do not imply that the increase in Atlantic tropical storm frequency since the 1970s will continue into the future. So that projection is not confidently done yet. These same models project future decreases in Atlantic tropical storm frequency in response to increasing greenhouse gas concentrations. Again, this is Atlantic storm tropical storm frequency. What does that mean for the global number? If the Atlantic storm frequency decreases, then does that mean others will increase to make up a increase in response to anthropogenic forcing, or will all of them remain the same or decrease? There is evidence for a slowing of tropical cyclone propagation speed over the continental US over the past century, but these observed changes have not yet been confidently linked to anthropogenic climate change, and this has not been this has been debated about whether it's also happening in other places. In summary, it is premature to conclude with high confidence that increasing atmospheric greenhouse gas concentrations from human activities have had a detectable impact on Atlantic Basin hurricane activity, although increasing greenhouse gases are strongly linked to global warming. So there are some parts that are clearly attributable, Some possible human influences on tropical cyclones are summarized above. Human activities may have already caused other changes in tropical cyclone activity that are not yet detectable due to the small magnitude of these changes compared to estimated natural variability or due to observational limitations. Okay, so we know greenhouse gases have gone up. We know that has caused warming. We know that warming comes with increased water vapor in the atmosphere. We expect certain responses of cyclones to that increased water vapor, like increased rainfall in cyclones. And sea level rise has increased because of the warming and the expanding water column. We expect that will bring increased inundation for the same category of cyclone when it makes landfall. But those steps have not been filled yet. But there are other arguments made that evidence does exist for hurricanes getting stronger. This is from Kerry Emanuel opinion in PNAS Proceedings of the National Academy of Sciences of the USA. Potential intensity trend for 1979 to 2018 from RFI reanalysis. We know what this is. Given the warming over this period, how the theoretical maximum pressure drop and wind speeds increased. So linear trend in potential intensity in meters per second per century in the color scale shown here. From 1979 to 2018, calculated from ERA 5 reanalysis dataset. Trends are only displayed where their p-values are 0.2 or less. So this is highly statistically confident. Confidence level is high, and there are evidences in these regions of Arabian Sea and Bay of Bengal, Southern Indian Ocean, and the Pacific regions and the Atlantic regions that potential intensity has gone up. So what does it mean? There is another way that Kosin et al. Have done it, where they have looked at exceedances. So here are the time series of fractional proportion of major cyclones estimates to all cyclones for the period of 1979 to 2017. Each point except the earliest, so the beginning, represents data in a sequence of 3-year period. So the idea is that proportion of major hurricane fixes over this period for the North Atlantic, Eastern North Pacific, Western North Pacific, South Pacific and Southern Indian Ocean have all increased. I should know what this is, but I'll come back and tell you that in a minute. Sorry about that. Sorry, those are Atlantic, Pacific and Indian Ocean multi-decadal variability. So you can see the Atlantic and Pacific are going up, and the Indian Ocean has a different behavior. Okay, altogether, for example, these exceedances are not completely attributed to anthropogenic forcing, for example. So this exceedances are real in terms of the proportion of major cyclones in each of the basins. Northern Indian Ocean is confused. As we said, it has to be split into pre-monsoon and post-monsoon. Bay of Bengal and the Arabian Sea. Bay of Bengal is not seeing much of a change, whereas the post-monsoon Arabian Sea has almost seen a double the number of cyclones per year. So there are changes in this sense, but they have to be related to anthropogenic forces with attribution exercises which are underway and will continue for a while. But you understand now the difficulties of actually describing the cyclone responses to global warming. It is not straightforward. It has to be looked at in terms of potential intensity, tracks, propagation speeds, amount of rainfall, inundation, the latitudes of maximum intensity, and so on.